Newton's second law of motion. Newton's second law states that the rate of change of momentum of a body is directly proportional to the force applied on it, and this change in momentum takes place in the direction of the applied force. If an object of mass m has velocity v, the momentum of the object is equal to mv. According to Newton's second law of motion, if force F is applied to the object, then F is directly proportional to d dt of mv. Here d dt is called derivative, which represents the rate of change of momentum. You can also represent the rate of change of momentum as m into v minus u divided by t, where u is the initial velocity and v is the final velocity of the object. However, now we need a constant to replace the proportionality symbol and place the equal sign there. This constant is taken here as k. So the formula is written as F is equal to k d dt of mv. Since the mass of the object is constant, the change happens only in velocity. Therefore, the force F is equal to k m dv dt. We also know the change in velocity is acceleration. Hence, we can write the symbol of acceleration a in the place of dv dt. Then the formula looks as F is equal to k ma. If we take unit force, unit mass, and unit acceleration, then we get k is equal to 1. Therefore the final formula looks as F is equal to ma. This is the formula for the measurement of force, where force is related to mass and acceleration. Force is a vector quantity because it has both magnitude and direction. Newton's second law of motion gives not only the magnitude of force, but also gives the direction of force. According to this law, the direction of the applied force is the direction of change of momentum, or the direction of change of velocity, that is the direction of acceleration. Now, if we talk about the unit of force, then the unit of force is equal to the unit of mass into the unit of acceleration. We know in the SI unit system, the unit of mass is kilogram, and the unit of acceleration is meter per second square. So the SI unit of force is kilogram meter per second square. This unit of force is called Newton. Similarly, we can write the CGS unit of force as gram centimeter per second square. This unit is called dyne. Definition of 1 Newton. The force acting on an object of mass 1 kilogram, causing an acceleration of 1 meter per second square, is called 1 Newton. As we defined 1 Newton, similarly we can define 1 dyne as follows. The force acting on an object of mass 1 gram, causing an acceleration of 1 centimeter per second square, is called 1 dyne. The relation between Newton and dyne is as follows. 1 Newton is equal to 10 to the power 5 dyne. As we find the unit of force, similarly we can find the dimension of force. The dimension of force is equal to the dimension of mass into the dimension of acceleration. We know the dimension of mass is m, and the dimension of acceleration is lt to the power minus 2. So the dimension of force is mlt to the power minus 2. Verification of the first law from the second law. From Newton's second law of motion, we find that F is equal to ma. Now, if no force is applied from outside, there is no change in the velocity of the object. The object continues to move with uniform velocity. If the object is at rest, it remains at rest. This is Newton's first law of motion. Within Newton's second law of motion lies the first law of motion. But Newton mentions the first law of motion separately, mainly to establish the concept of the inertial frame of reference. Here, I want to clarify that the inertial frame of reference is not related to the acceleration. It only relates to the object that is in rest or moving with uniform velocity. If acceleration is considered in the motion of the object, then it is related to the non-inertial frame of reference. But in this frame of reference, none of Newton's laws of motion are applicable. I will deeply discuss the concept of the frame of reference in another video. So, stay with us.